Hi, I've just made a video on showing how to integrate the product of functions. So if I've got a function, although in my example here to illustrate, I'm just showing u and w, but in my actual example I actually used f and g. But in this case, just show if u and w are both functions of x, the integral of uw is u times the integral of w dx minus the integral of the product of du by dx times the integral of w dx, all with respect to dx. So my other video just showed that, how to integrate a product, but it's actually just used f and g instead of u and w. So what I'd like to do in this video, I would like to use that principle to show how to integrate the arcsin of x. So the three ways you can write arcsin x, asin x, or sine to the minus 1x. So sine to the minus 1x, or arcsin x, or asin x, that's the angle whose sine actually is x. And of course, when you're doing trig, or so calculus with sines and cosines, obviously it's assuming then the x is radians. So what I want to do here is then I want to use that product rule to integrate the arcsine of x, or sine to the minus 1x, or a sine x. So what I do is, to integrate that, I'm going to turn this into a product. So the use of the first function is the sine minus 1x itself, and then the second function is basically just a function 1. So I'm basically integrating a sine x times 1 with respect to x. Okay, so the rule then is just take the first function on its own, sine to the minus 1x, integrate the second one, which is 1. So I've got sine to the minus 1x all times x, and then I've got the integral of the derivative of sine to the minus 1x times the integral of the 1 dx. Now, as I've showed, I think in the previous video, to differentiate sine to the minus 1x, that's 1 over the square root of 1 minus x squared. And I think I've got a video to show that. So that's the first expression in the second term of my equation. And then 1 dx, that's the second function from the 1 which is being integrated. So let's develop this now. So I actually get x, so for the first side then, I actually get x to the sine minus 1x, x times sine minus 1x, and then I'm subtracting the integral of x, so the 1 then, that integrates just to give me x. So the first function was the derivative then, which is 1 over 1 minus x squared. So the second term then, it's the integral over x over 1 minus x squared with respect to x. So what I do is, I'm going to substitute now. So the term 1 minus x squared, I'm going to call that u, and that means then that du by dx equals minus 2x. So going back to my main equation, x sine to the minus 1x times, so the 1, the square root of 1 minus x squared, that's just the square root of u, and then du by dx, that's minus 2x, which means then x itself is minus a half du by dx. So the x which is in the top line, I'm going to replace that with minus a half du by dx, integrating everything with respect to x. So first term's unchanged, x sine minus 1x, and then I'm integrating 1 over the square root of u, because see, I've got two minuses here, so the two minuses there, like this minus and then this minus, to make the plus. So I've got plus 1 over 2 square root of u, and the dx's cancel out, so I'm actually integrating that with respect to u. First term still the x sine minus 1x, and then if you integrate 1 over 2 root u, you actually just get the square root of u. And then, so that's x times sine minus 1x. I want to expand u in terms of x again, which is 1 minus square root of 1 minus x squared. So the square root, so the integral of sine minus 1x dx is x sine minus 1 dx plus the square root of 1 minus x squared plus c. Okay, and thanks for watching. Hope you enjoyed that. Thank you and goodbye.